Welcome to our bonus video of making the protective roll cage for our quadcopter built in the first two tutorial videos. We'll take you through the process of how we took a 3D printed part, made a two-piece silicone mold from it to cast a high-impact polyurethane. First, we begin the process of creating a round block to place our pattern onto, defining the split line of the mold and preventing an undercut. We also have some registration keys mounted to the baseboard. We use modeling clay to fill any gaps where the part meets the block and baseboard. Once finished, we start to build a mold box around the pattern to pour our silicone into. The walls are hot glued to the base and each other to create a watertight seal. A light spray of zip mold release will aid in pulling things apart later. We're ready to mix and pour our mold silicone. Here's the first mold half after the silicone cures and walls removed. We need to pull the wood block out before casting the second half of the mold. A wood screw is used to provide leverage in extracting the block. There will be modeling clay that needs to be removed as well. Carefully cleaning it out with a rounded sculpting tool only takes a few minutes. We glue our vents and fill port onto the desired points. We want to tilt the mold, fill from the low point, and vent from the high points. We're about ready to apply zip mold release to prevent the second silicone mold half from sticking. You can use a small acid brush for hard to reach areas. Spray release over everything. Form a mold box around the first half, and then cast the second silicone mold half. Once the silicone cures, pry the two silicone mold halves apart and remove the 3D printed pattern. The mold is prepared with a pour funnel and vent straws before pouring in the casting polyurethane. The A and B components are carefully measured with a little orange pigment added for color. We mix thoroughly in alternating circular motions using a flat stirring spatula. To be sure no streaks of unmixed material are hiding on the bottom and sides of the cup, we transfer into a new cup to ensure a fully blended mixture. Then, we place our polyurethane material into our vacuum chamber to remove trapped air bubbles. Vacuum is applied for 45 to 60 seconds. A strong pump is essential in properly degassing casting materials in a timely fashion. With our material degassed and our mold tilted up at an angle, we pour the mixed polyurethane into the pour funnel. The height of the narrow funnel adds additional hydraulic pressure to force material through the narrow mold cavity. Folding the end of the funnel and squeezing adds even more pressure if the viscosity of the cast material is slightly thicker than normal or the system is extremely fast. Material rising out of the vents indicates the mold is completely filled.
Okay, so at this stage, we've got our silicone mold, we've cast the polyurethane part. Now let's recap why we go through all this trouble of making the mold to then cast parts. So, we've got a 3D printed part here, and it did take some work to get it to a nice finish. And if we had to do this to every single part, it's going to increase the amount of time and effort to make every single part look nice and look the same. So by making the mold, all the parts up until a certain point are going to look relatively the same. They're going to have a nice shiny finish just like this part. But the beauty of it is that we've got a very large variety of cast urethanes that we can do and cast into this mold for a variety of properties. This particular material, this is the FD70. We've been able to pigment it a nice bright orange, which we could change if we want to. If we want to do a black one, that's fine. Bright red, yellow, we can do a lot of that just by changing the pigment we want in that cast material. So this cast piece, it's all homogeneous. It's all, there's no build lines, there's no layer bonding line issues, as opposed to some of these FDM printed parts that in some applications you could get a force on it that's going to cause it to break in one direction, maybe not the other. So let's, to demonstrate, you're probably wondering why I have some safety equipment over here. Once again, this semi-rigid FD70 material is very, very tough material, and I'm going to show you how and why. This is not a foam hammer. This is a real hammer, okay? So, all right. This stuff's not going to break. Not with a hammer, okay? This is the cast piece. Try that again. Well, there we have it. It's high impact. It survived a launch across the room with a hammer. Let's try it with the ABS piece. Oh, that didn't take long. So, good illustration of why we might want to use a cast urethane pieces as opposed to just using the raw 3D printed parts. So in certain situations, you just need more performance, you need higher impact, or you need a little bit of give, or certain stiffness or flexibility to deal with the application. This is, once again, it's a good way to pop out lots of parts for relatively low cost, and it's repeatable, and it's done in a short to medium run production setting, and this is done all the time with a ton of our customers, and this is why we do it. So there we have it. This is a good example of why we looked at urethane casting to do this type of a part. If you have any questions, leave some comments in the video below and let us know what you think. Thanks a lot.